Okay, you'll notice that these videos currently are a little on the quick side, and that's because the book is more than enough for what you need to do a lot of these. And what I'm doing in the videos right now is I'm sort of, one, trying to wean you off the videos for the most part, and two, just providing alternative information or a diversion or giving you some extra help or encouragement. So the statistics engine, the main thing I want to show you, because the book covers how this works and what it should do, and this is a useful algorithm for calculating statistics when you don't want to store all of the elements of the array used to calculate the statistics. So it's a rolling statistical analysis. Now it has some flaws, which we'll get into. But the first thing I want to do, and this statistics engine, this little statistics engine is super useful. You can just sprinkle it all over the place because it's so fast and get some basic instrumentation on most of your systems. What I want to do is I want to compare the test versus R to confirm that it works, because R will do the calculation in the standard way, and I've done my calculation in sort of a strange algebraic alteration of it to make it rolling. So let's just do that. So the very first thing is you're going to need to go get, make sure I have it somewhere, R. Now R is super handy and it's great to use, but it's kind of a gnarly programming language. But if you're looking for more programming languages to run, R is a very nice programming language to run, especially for statistics. And miraculously, when you search for the letter R, you actually find R instead of something else. So once you go there, there's a download. I would actually just search for OSX download. That's your best bet. Because if you do OSX download and grab it like that, then you grab this package and you install that package there. And I'm using 3.21, but the calculation is as old as statistics pretty much. So you can just use the any version, to be honest. And I have my handy screen down below, so I'm going to be switching windows. So just watch where the blue is. So right now I'm in R, and then this is lib, learn C the hard way. Okay, so I'm going to first make clean and make, just to confirm, oh, I have actually done some modifications. This is interesting. Clear, make clean, make. Oh, let me pause while I fix this. Okay, sorry about that. I had leftovers from a previous video. There we go. When I was demonstrating code reviews. Okay, so what we have is it builds, and it's got all the tests in the test directory, so we can run the one test that does stats. And we can get its version of statistical information on our data set. Now I just picked a sort of randomized data set. So now I'm going to load this data set into R, and I'm going to compare it. And what I did is I used R to do calculations for those for these expected elements in stats. So now I pop over to R, and in R I'm going to do the R syntax, which is that. So you see R sort of runs like Python with like a command line, right? Okay, so I have R, I've got my data. Now I can do two things. I can do stest. That gives me a lot of the statistics that we calculate, and I can do SD on stest. That gives me my standard deviation, and that gives me that on stest. Now to compare the two. So first thing, let's go look at mean. This is a more accurate mean, and my mean is 5.584620, 5.584602. There we go, accurate. Okay, next I want to test standard deviation. 3.5, let me find 3.54 right there. Okay, 547,868, that works there. And then I want to do min 0.33348, and that's my min there. And max 9.675, that is my max, that's confirmed. And sum squared, we don't have a calculation for that, but we could probably dump that if we wanted from R. And the count is 10, and it should be the same count. Okay, so there we go. So we've confirmed it, but now I want to go double check that the test actually outputs the dump. So let me just make a small modification. I think that's the correct part. Just like this, so I can do the comparison. Make that build. Rerun it. Yep, stats dump and end, and that was what I was looking at. Awesome. In fact, I'm just going to do a little more fancy. There we go. And there. So I just wanted to confirm that I wasn't printing out my expected values. Instead, I was actually printing out what was calculated. And stats create, number of samples, I ran through my sample, and there you go. So it's good when you're doing math to use the math that other more experienced and better mathematicians have used. Okay, so breaking it. This is a rolling calculation. So the difference between a rolling and a normal calculation of all these variables is that normally you hand all of the data to a function like summary or mean, and it runs the calculation over all elements. Okay, the stats, though, that I'm doing are meant to just only store this statistics structure. And what it does is it does it by just doing some sort of like some math wizardry, where if I find sample, okay, so what it's doing is it keeps around all the state of the statistics calculation that you would have if you were to roll through these, and then just recalculates it on the fly. Okay, so the Achilles heel of this is if someone hands you, say your sample comes in, if they have control of the data going into the sample, they can hose your sample by just, passing in some really terrible high number or low number, and the whole thing is ruined because you can't recover the state. But this rolling calculation is really useful because you'd only have to store these, 4 or 5 variables, and that's it. Extra credit. So try using the static inline functions. Hopefully you've sort of figured out what those are. I use them occasionally. They're sort of like a way to do macros, but as actual C code. They have certain limitations, so go research that. Use this code to write a performance test of the string algos test. So make it so you can run the string algos test, but use stat to confirm that it works the way as expected. And write a version of this in another programming language confirm that this version is correct based on what you have here, and verse on what R is. Write a little program that can take a file full of numbers and spit these statistics out for them. Make the program accept a table of data that has headers in one line, then all the other numbers on other lines, and separate it. And then your program should then print out these statistics for each column by the header name. So that's a pretty big project, but it could be a useful little tool. Right, that's the end of lecture 43.